Hello, and welcome to the presentation for Smart Search, an artificial intelligence-fueled software that helps users to get missing information from images they find on browsers and social media in place of taking screenshots. Once the idea was formulated, background research on the topics of screenshots and image searching was conducted along with different AI technologies. Research on screenshots found that they are an intuitive and fast way to formulate queries, but the ease of creation and diversity of topics causes a large backlog of photos. Research on image searches and how they work confirm that image data is more voluminous than textual data, but also must be processed using content-based image retrieval software that can extract certain features for accurate photo retrieval. This type of software is fueled by deep learning convolution neural networks. One of the main competitors for the proposed software is Google Lens, which uses vision-based computing capabilities to provide information that users can take action on. The proposed software instead would use two types of artificial intelligence: computer vision and recommendation engines, both of which produce meaningful information that users can take action on. The methodology used to create this product was Lean UX, which uses a cyclical think, make, test approach that would be repeated in the future to improve the product. The steps taken in the project include quantitative and qualitative user research, affinity diagramming, priority assumption matrix, mental models, creation of a proto-persona and corresponding empathy map, customer journey map and storyboard, user flow, creation of a problem statement and hypothesis, an interactive high-fidelity minimum viable product, and 5-act interview test results. Additionally, a Lean UX canvas was filled in throughout the project. User research was collected through a questionnaire and user interviews. The questionnaire was created on Google Forms and received 24 responses. The answer highlighted here was valuable for the assumptions that would be made later in the process and was used to get further clarification from the interviewees. 2 interviewees participated in semi-structured interviews about their screenshot and image search habits. Following the completion of the interviews, keywords and quotes were coded into motivations, events, actions, obstacles, communications, and outcomes before being grouped into themes. Key insights were circled for further evaluation. 18 business and user assumptions were constructed based on the research done, and the assumptions that could be placed on a priority matrix were rated based on effort and impact. Of the 9 assumptions in the priority matrix, 4 are in the high effort, high impact quadrant, the highest of which has to do with the creation of the artificial intelligence algorithm required for the software to come to life. Next, a brief proto-persona was created with demographics, motivations, frustrations, and goals, along with an empathy map outlining what said proto-persona thinks, feels, sees, heard, says, and does, along with their pains and gains. To get further insight into this proto-persona, a mental model was created outlining the thoughts, behaviors, and feelings associated with each step of the current process: taking, using, and deleting or forgetting about a screenshot. Additionally, a customer journey map and storyboard was created to associate further emotion, needs and pains, and potential opportunities for each step. Before moving on to the make stage of the project, a user flowchart was created to understand the future state, or the order in which the proposed software will work. This helped decide the order in which tasks should be done and screens should be made. The problem statement that inspired the proposed software is: screenshots were designed to allow for users to capture a moment in time on screen for sharing and future use. I have observed that current screenshot practices are causing users to lose sight of the purpose behind their screenshots, thus creating extra tasks and mental energy later on. How might we improve screenshots that are taken and stored so that our customers are more successful at using them in the moment and finding products and information from them? The hypothesis created to test the viability of the proposed software is: I believe that we will achieve screenshots funneling into e-commerce and taking up less space in galleries and cloud storage if the user can achieve the finding of wanted information from screenshots with this AI scanning feature. The high-fidelity interactive minimum viable product was created in Figma and consisted of 53 screens and 7 flows with 8 tasks. The screens highlighted here show 4 aspects of the app. Firstly, there are 2 ways in which users can enable the search and scan features. The originally conceived idea was that users would go through the control center, then draw a bounding box with their finger. The alternate method, once enabled, is to select and hold the image. Once the image is scanned, it returns results with relevant links and offers AI-generated keywords as well as a way to add custom tags. Links can be shared or saved directly to browser bookmarks. Your collection of searches is organized into AI-generated categories, but these can be hidden, shown, or customized according to user preference. Users can follow up on their results and revisit the link or delete the result altogether. They can also enable notifications so that they will be given reminders by the software to follow up on their results. The prototype was tested on 3 participants and 5 ACT interviews. This slide outlines the tasks asked of participants and the debrief questions. The feedback provided by the participants was used to create a to-do list for future iteration. The hypothesis was found to be approximately 40% accurate, with some ideas not possible to test based on the inability to create them in the time period. The to-do list here covers 3 areas: the placement of the software in the context of the phone's operating system, specific interface changes, and changes to the user flow that could make the product more likely to certify the hypothesis. Thank you for watching this presentation.